Okay, this is the targeted tutoring on food chains and food webs. Does everybody have a sheet of paper? Go ahead and title it Food Chains and Food Webs. Can I hold on? Yeah, I'm going to give you some time to write that down. Thank you. You can put targeted tutoring, or you can just put, you don't have to put that. So today we're going to talk about food chains and food webs, how food chains basically show how energy moves through an ecosystem. Yesterday we talked about photosynthesis, and we talked about how the plants turn the radiant energy from the sun into what kind of energy?
Chemical energy.
Chemical energy. So when we talk about energy flowing through the ecosystems, we're talking about chemical energy in the form of what? Yes?
What is that word again? By tutoring?
Targeted. What is chemical energy? When we eat it, what are we eating?
We're eating glucose.
Food. Food. So when we're talking about energy flowing through the glucose is also correct. Thank you. That was actually like the super science fantastic answer. We are eating glucose. So when we're talking about energy flowing through the ecosystems, we're talking about that chemical energy that's stored in the bodies of living things. So whenever you eat something, you're eating the body of something that was alive. Like if you're eating bread, you're eating wheat that was a plant before it was made into bread. If you're eating chicken, you're eating a dead body of a chicken. I know it's gross to think of it that way, but you're eating the dead things that were once alive that have energy stored in their bodies. What's up, Faith?
Because I have these plants that are in my yard.
Uh-huh.
Whenever I don't cut my grass, and they have like those little beads on them,
Mm-hmm.
it pops out. Can I turn that off and then wait till it dries out and use that?
Yep, those are seeds. Use them for food or use them to plant more plants?
Well, what can I use them for food as bread or corn?
It would just be grass seed, so I don't know that it would be a good thing to eat. I mean, you would probably have to be in like a survival situation to like break down and eat grass seed.
Yeah.
But you could do it for fun. Let me know what happens. Okay. These are food chains. Yo. So, food chains are the very simplest. And it starts with always, 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 what type of organism is the start of every food chain?
A plant.
A plant. Producers. Very good. People who are using my super science words there. Producers. So, we know that producers get energy from what?
From the sun.
From the sun. Do animals get energy from the sun?
No.
No, they do not. So there's our sun, and it's giving energy to the plants. So notice the way the arrows are pointing. They're pointing to where the energy is going. So a lot of people who have trouble with food chains, they put their arrows going the wrong direction. Really, that's the only trouble we see with food chains because they're just so simple. When you're talking about a food web, you're just doing a food chain that is, well, it just is made up of a bunch of food chains that are all interconnected. So I can make a food web out of these three food chains, right? I can say, well, the rabbit would probably eat corn if it got some. The grasshopper would probably also eat corn if given the opportunity. Rabbits also eat grass. Snakes would also eat rabbits if they're small enough. These large birds of prey eat rabbits. Owls can eat snakes. Snakes eat mice. So if you're looking at where the arrows are going, the arrows are just going to what is doing the eating, what is receiving the energy. Does that make sense? Let's see. Frog's not really going to eat anything else on here.
Is that a lion? Yeah, right.
That's a lion. Everything looks like a real animal, and the lion is like super cartoony, which is weird. The lion would probably also eat a rabbit if there are rabbits in Africa, which I don't even know if there are. Foxes eat little mice.
A bird would eat a rabbit?
A large bird like a hawk would eat a rabbit.
Oh.
The hawk would also eat a mouse.
You couldn't eat a fox, right?
So I just turned these 3 separate food chains into a food web. Now it's a food web, which is just a bunch of interconnected food chains, and they show more complicated relationships. Does that make sense? I'll give you a minute or so to take notes on this. You don't have to draw this whole thing out, because that's just going to take a really long time. But make a note about what a food chain is. We'll talk about where the arrows go on the next slide. Okay, y'all ready? All right, I wrote this last night, and I thought it was going to, play it, but it didn't. Oh, well. It says, what do the arrows show? They show where the energy is going. So I drew this lovely picture of the sun giving energy to the grass, which gives energy to the bunny, and the bunny says, yummy. So we're going to write that down. What do the arrows show? They show where the energy is going. I'm going to redraw these arrows because these are super ugly.
Oh, man. Miss, I bought you that pencil thing, but I forgot it. It's
Oh, you bought me a stylus?
Yes.
Oh, that's
it
super
has
nice.
The thing on top, and you can turn it to a pen and actually write with it too.
That's pretty cool. I would have really loved to get that.
Well, I have it, but I just forgot it.
Okay.
I'm sorry.
That's okay. I'm not going to punish you. I'll forgive you just this once for not bringing me a present.
Wow.
Okay, so the arrows show where the energy is going. I can't stress that enough. That's the big main problem that most people who struggle with this concept have. And we'll talk about the other main problem that we have when we're all done writing this one down. Draw yourself this little diagram. The sun gives energy to the plants, which gives energy. I just drew a rabbit. You can draw anything that eats plants. And that rabbit is also not great.
Also write yummy.
You can write yummy if you feel so compelled.
Wait, Miss, I have a question. You said where the energy is going, so the sun can eat grass.
No. The sun gives energy to the grass. See how the arrow is pointing toward the grass?
Oh, and then the grass gives energy to the rabbit because the rabbit eats grass.
Correct. So the arrows point to where the energy is going. So the energy starts with the sun always. It goes into the plants. The plants do photosynthesis, and they turn the sun's energy into chemical energy in the form of glucose. And then the plants have all the energy, and then the energy flows from the plants to whatever eats the plants. So when you eat a plant, like when you eat carrots or potatoes or fruit, you're getting energy from that plant. Even though it's like you get it in the grocery store and you don't see it actually growing on a plant, if you're eating strawberries, they grew on a plant. If you're eating apples, they grew on a tree. Does that make sense?
Yes.
Okay. Does anybody need more time on this one? No? Okay.
I think
We're just drawing the bunny. Okay, so food webs show complex relationships in ecosystems. So this is a very complicated food web.
Do you have to excuse me? Do you have to write that?
No, you don't have to write this. We are going to talk about some of these relationships, though. So I'm erasing this. Always start with the producers because it's just taking up too much of the picture. So this is a Chesapeake Bay waterbird food web. And I guess it's called the waterbird food web because the water birds at the top are the tertiary consumers. This reviews a couple of good things. On the left-hand side, you see these labels. These are trophic level labels. Primary producers, herbivores, primary consumers, secondary consumers, tertiary consumers. Primary consumers are herbivores, so that should be combined. Does that make sense?
Yes.
Okay, so you've got producers, primary consumers, secondary consumers, tertiary consumers. And what I want you guys to start understanding about food webs is that they are, it's all interconnected. So questions that you're going to get are going to ask things like, what would happen to the food web if the bivalves all died? So here we're going to like draw a box around the bivalves. Bivalves are just like these muscle clam looking things. Do y'all see the box that I drew around it there? So when you're talking about the relationships in food webs, if I say all the bivalves are gone, actually I don't like that box very much. All the bivalves are gone. So then we're going to look at everything that's connected to the bivalve. So if all the bivalves are gone, what's going to happen to the things that eat them? They might die if that's the only thing that they eat. But what if you eat bivalves and you also eat benthic invertebrates? What's going to happen? So let's look at the sea ducks right here. The sea ducks here, you can see they get energy from two different places. They get energy from the bivalves, and they get energy from these benthic invertebrates. So what's going to happen to this population of sea ducks if half of what they eat is gone?
They're going to decrease.
It's going to decrease. I love that you said decrease. So whenever we're talking about populations, they're either going to increase, and what would cause a population to increase? What's one thing? There's lots of things that could cause a population to increase. What's one thing?
More of what they eat.
Good. They get a lot of extra food. It rains a whole lot. The grass grows really tall. Lots of grass is there available. So they have a lot of food. What else could cause a population to increase?
If, like, the animals that they prey are, like, gone.
Good. If the animals that eat them decrease.
Yeah, they die.
So if I'm this sea duck here and the bald eagle population goes down, my population might go up because nothing is hunting me. Look, that's the only thing that hunts the sea ducks. So if the only thing that kills me and my family is gone, then me and my family get to survive and our population would increase. So let's look at the bivalves again. What's going to happen to the sea duck population if the bivalves are gone? It's going to decrease, right? What about the tundra swan?
No.
Tundra swan gets energy from vegetation, which is plants, and they also get energy from bivalves. So are they going to decrease or increase or stay the same, you think? Why do you think they're going to decrease, Karime?
Because instead, what's it called?
The bivalves?
So that's going to be gone, and they're just going to eat the vegetation and the other swan.
Well, they don't eat the other swan. You can see there's only 2 arrows going into this tundra swan right here. So their population is going to decrease also. Does that make sense? What about, let's see, what do the bivalves eat? They eat zooplankton and they eat phytoplankton. So what's going to happen to the phytoplankton population if the bivalves all go away? They would increase because they have less things eating them. What about the zooplankton? They would also increase because they have less things eating them. Do you see how this is all kind of connected? What would happen to this small planktiferous fish if both the phytoplankton and the zooplankton populations increase? What do you think would happen to their population?
They will increase too.
That would increase too because they're going to have a lot more food. So if there's a lot more of those, then what's going to happen to all these other things?
They will increase.
They're going to increase too. And then it'll eventually work itself out to where it'll come back down because if you get all of these predators increasing in populations, there will eventually be so many of them that they will eat all of those little fish, or they will eat a lot of them, and then their populations will decrease. So populations kind of go, let me see if I can make just a new, they kind of go on and off. Where can I do a new slide? Okay. Nothing is simple. So here's they oftentimes draw population graphs that look like this. and they'll do,
Oh, with like the names on the bottom. And then
so we'll say that this is a small fish. And then what was it that was eating the small fish? Some kind of bird.
eagle.
So if the population of small fish goes up, then the things that eat them will go up here. And then they'll start going down because a lot of things will be eating them, and then what eats them will go down.
Are you supposed to draw that?
You don't have to draw this, no. So oftentimes you'll have a cycle like this where the prey animals, these are the prey, they will have fluctuations. Their population will increase, and then the predators' population will increase because there's so much food to eat. And then when there's lots of predators, they'll eat all the food, and then the prey population will go down, and then the predators won't have as much food, and so then their population will go down, which will make the prey population go back up because there's not as many predators. So it's kind of this like nice little cycle that balances itself out. Does that make sense? Okay. That was a little side note. In conclusion, we're pretty much done here. Food webs and food chains show feeding relationships. You guys can write this down. Arrows show where the energy is going. And I added a little note there. They point to the thing that is eating the other thing. So the arrows are always going to point to whatever is eating that. Relationships are complicated and they're interconnected. And whenever we're talking about changes in the ecosystems, we talk about, we express them in terms of the population changes. So the population goes up or the population goes down. We try not to say everything will die because that's oversimplified. But populations go up and down in natural cycles. Yes?
What does it say after our relationships are?
Complicated?